Hey everyone, today we are going to solve the Daily LeetCode challenge of 14th March 2024, and the problem statement is binary subarrays with sum. So let us first understand the problem statement. So according to the problem statement, we have been given a binary integer array, nums. So it means that it contains only ones and zeros, and it won't contain any other digit except for 1 and 0, okay? And we have been given an integer goal. And what we have to do is we have to find the count of subarrays. Count of subarrays that has a sum equal to this goal. Okay, sum equal to goal. So what does it mean? It means that we have to find out that how many subarrays are present in this nums that has a sum of 2. Correct? Now let me first tell you that what is a subarray. A subarray is a continuous part of an array. It is a continuous part of an array. So let's see, is this 1 0 a subarray? So this 1 0 is a subarray. Why? Because it's continuous, right? We are not missing any elements in between. Now, if I'll ask that, is this 1 1 a subarray? So the answer would be no. Why? Because we are missing out this 0, right? And it's not continuous because we are leaving some elements in between. So it's not a subarray. So let us now see that what is the count of subarray in this nums that sums to 2. So here you can see that we have this 1 0 1, correct? So this 1 0 1 has a sum of 2. So we have 1 0 1. Additionally, you can see that we have 1 0 1 0, correct? We have 1 0 1 0. This also has a sum of 2. Now here we have this 0 1 0 1. We have 0 1 0 1. This also has a sum of 2. And we have this 1 0 1, correct? So we have 1 0 1. So what is the count of subarray that has a sum of 2? There are total 4 subarrays. So the answer to this example would be 4. Okay. Now let's see how we can solve this problem. So I'll be discussing two approaches for solving this problem. Let us first discuss the approach 1. So in the first approach, what we will do is we will keep track of the prefix sum. Okay. And we will use a hash map. And what we will do is we will check that if a prefix sum minus this goal, okay, if this exists in our hash map, then it means that we have got a subarray that has a sum of 2. Now let me explain this in a better way. Say for example, these are some of the elements. Let's say these are some of the elements. Okay. Let's say these are some of the elements of an array. Okay. And what is prefix sum? Say for example, if I'm present at this point. So what is the prefix sum? Prefix sum means sum of all the elements up till here. Correct? So let's denote the prefix sum over here as P1. Okay. And let's say that if I'm present over here, then what is the prefix sum? Prefix sum is the sum of all the elements up till here. So let me denote its prefix sum as P2. Okay. So we would have encountered this P2 before this P1, right? It is obvious because we will be moving from left to right. Okay. So we would have stored the prefix sum of this place in the hash map and then of this place in the hash map. So let's say we have stored the prefix sum P2 in the hash map. And let's say its frequency is 1. Okay. And now we have got, and now at this point, we have got a prefix sum. Say, for example, it's P1. Okay. And now let's say if this P1 minus goal, what is goal in this example? It's 2. Okay. So say if this P1 minus this 2 is equal to this P2. Okay. So if we have found that the prefix sum of this place, the prefix sum at this point minus the goal exists in the hash map. Say for example, it's equal to P2 and P2 exists in the hash map. So what does it mean? So let me shift the place. Let me send this 2 over here. So we will have P1, and if we'll bring this P2 over here, so what it would be? It would be P1 minus P2 equals to 2. So what does it mean? It means that the prefix sum up till here is P1. The prefix sum up till here minus the prefix sum up till here. Correct. So it means that minus the prefix sum up till here is 2. So it means that this one minus this one. So if from this entire prefix sum we are going to remove this one, so what does it mean? It means that we will be removing this part. Correct. So we will be left with this part. So what it means? It means that the sum of this part of the subarray is what? It's nothing but 2. Right. So that's the reason why we will be checking that whether the prefix sum, the current prefix sum minus goal already exists in our hash map. If it already exists, then it means that we have found out a subarray that has a sum of this goal, right? In this case, our goal was 2. That's the reason why I have written this 2. But if we generalize this, then what does it mean? It means that if we have a prefix sum P1, and if we will subtract goal from that, and if we get a prefix sum, say for example, it's P2, which is already present in our hash map, then it means that we have got a subarray that has a sum of 2, correct? Let's say we will be taking a variable answer, which would be initially 0, okay? And what we will do in the hash map, we will use this hash map to keep track of the prefix sum. So what we will store? We will store prefix sum and the corresponding frequency, that is how many prefix sum we have got right up till now. So that's why we will be storing frequency, because we need to find the count, right? So it makes sense to store the frequency of that prefix sum. So whenever we'll get this prefix sum minus goal, okay, whenever this exists in hash map, what does it mean? It means that we have got a subarray with a sum of 2. It means we have got a subarray with sum equal to this goal, with sum equal to goal. So what we will do, we'll simply add the frequency of that, right? So we'll say the name of hash map is frequency only, FREQ, okay? So what we'll do, we will add the frequency of this particular element, right? Whatever prefix sum exists. So we will add prefix sum minus goal. The frequency of this we will add to it, right? One more thing to notice is that whenever our prefix sum will be equal to the goal, in that particular case, what does it mean? It means that we have got a subarray that has a sum of goal, right? We will get this at a very initial stage. So in that particular case also, what we will do, we will add 1 to our answer, because what does it mean? It means that we have got a subarray that has a sum of goals. So we have got a single subarray, so we'll simply add 1 to it, okay? So let's do a quick dry run. So this is our array 1 0 1 0 1, okay? So currently we are present at this element. Initially our prefix sum would be 0. So since we are currently present at this 1, so now what would be our prefix sum? Our prefix sum would be, let me write here, prefix sum. Initially prefix sum was 0. Currently we are at 1. So we will add 1 to our prefix sum. So we'll get a 1. Now what we'll do? We'll check whether this 1 minus what is the goal? Goal is 2. Whether this 1 minus 2, that is minus 1, exists in our hash map? No. So what we'll do, we'll simply add this to our hash map. So we will add the prefix sum 1 and we'll add its frequency 1. And we'll move forward. Now what we have got? We have got a 0. So we'll add it to our prefix sum. Our prefix sum will still remain 1. So again, we'll check that is 1 minus 2 exist. So it doesn't exist. So what we'll do? We will increment the frequency of the prefix sum we got up till now. So it would become 2. Now we'll move forward. So we have got a 1. So we'll add 1 to our prefix sum. So we'll get a 2. Now we'll check that this prefix sum minus goal exists. So what is the prefix sum? Prefix sum is 2. So what is the goal? Goal is 2. So 2 minus 2 is what? It's 0. So does 2 minus 2 exist? That is 0 exist in our hash map? No, it doesn't exist. So we'll move for checking the second case, which is this prefix sum equal to goal? So we can see that our goal is 2 and our prefix sum is also 2. So what does it mean? It means that we have got a subarray that has a sum equal to goal, correct? And what is that subarray? That subarray is nothing but this 101, correct? So what we'll do, we'll simply add 1 to our answer. So what we'll do, we will add 1 to our answer. And what we will do, after adding 1 to our answer, we will store this prefix sum in the hash map. So what is the prefix sum? The prefix sum is 2 and its frequency is 1, correct? Now we'll move forward. So we'll reach at this point. Now we'll add 0 to our prefix sum. So what is the prefix sum? Our prefix sum will still be 2. Now we'll check, does 2 minus 2 exist in our hash map? So it doesn't exist in our hash map. Now we'll check for the second case. Does this prefix sum equals to the goal? So we can see that our goal is 2 and prefix sum is also 2. So what we'll do, we'll simply add 1 to answer. So we'll add 1 to answer. And what we will do, we will increment this frequency of this 2 from 1 to 2, because we have got a prefix sum of 2 one more time, correct? Now we'll move to the next element. So the next element is 1. So we will be adding 1 to our prefix sum. So what is the prefix sum now? The prefix sum is 3. Now what we'll do, but before that, let me show you that what is the subarray that we have added over here. So it's this one. Okay, fine. So what is the prefix sum that we got now? We got a prefix sum of 3. Now what we'll check? We'll check that whether this prefix sum minus goal exists. So what is the prefix sum? It's 3. What is goal? Goal is 2. So 3 minus 2 gives us 1. Now we'll check. Does this 1 exist in our hash map? So we can see that this 1 exists in our hash map. So what we will do? We will add the frequency of this 1, right? We will add the frequency of prefix sum minus goal. So what is prefix sum minus goal? Prefix sum minus goal is 1. So we will add the frequency of it to answer. So what is the frequency? It's 2. So we will add this 2 to our answer. So we will get 4. Now what we'll do, we'll move forward. Now we have completely exhausted this num. So what does it mean? It means that we have no more element to process and this is our answer. So our answer is 4 and we can verify that the correct answer was also 4. So this is how we'll be solving this problem using the first approach, in which we are keeping track of the prefix sum, and what we are checking whether this prefix sum minus goal already exists or not. If it exists, it means that we have got a subarray that has a sum of this goal, and what we'll do, we'll simply add its frequency to our answer. Okay. Additionally, if we get a case where our prefix sum becomes equal to goal, in that case, it means that we have got a subarray that sums to this goal. So what we'll do, we'll simply add 1 to our answer. We can say that we'll simply increment our answer, right? So let's code this. So we'll start on by taking answer initially as 0 and prefix sum initially as 0. Let's take an unordered map. It would be of type int comma in. Let's call this as frequency. And what we'll store? We will store prefix sum and its frequency in this hash map, right? Now what we will do? Now we will simply iterate over the elements of nums. So let's say for auto, current is to nums, right? Now what we have to do? We have to populate this prefix sum. So what we'll say? We'll say prefix sum plus equals to current, right? Now after that, what we have to do? We have to check whether this prefix sum equals to goal. So if we get a situation in which this prefix sum equals to goal, so it means that we have got a subarray that has a sum of goal. So what we'll do, we'll simply increment our answer. Otherwise, if we get a situation in which our prefix sum minus goal already exists, right? So in that case, what we'll do, we will add the frequency of that prefix sum minus goal to our answer. So what we have to do, we have to check if this prefix sum minus goal already exists. So if it already exists in our hash map, what we'll do, we'll simply add the frequency. So we'll say that prefix sum minus goal. So we have simply added its frequency to our answer. Now finally, what we have to do, we have to return this answer. Additionally, what we have to do, we have to also store this prefix sum in our hash map, right? So we have to also store this prefix sum in our hash map. Now let's run this. So we are getting the correct answer. Let's submit it. And it got accepted. Talking about the time complexity and space complexity. So if we consider n as the size of the nums array, then in that case, the time complexity would be order of n. Why? Because here you can see that what we are doing, we are iterating over all the n elements of this nums array to find the prefix sum, correct? So therefore, the time complexity would be order of n. Additionally, the space complexity is also order of n. Why? Because we are storing the prefix sum in this hash map. Now, in the worst case, it could be possible that all the n prefix sums could be distinct, correct? So we will be having a total of n entries in the hash map. So that's the reason why, because the space complexity is also order of n. So that was all about the first approach. Now let's quickly discuss the second approach. So now that we have seen that the previous approach was taking us a time complexity of order of n and a space complexity of order of n. So can we have a better solution in terms of space complexity? That is a solution that will cost us a space complexity of order of 1. So the answer is yes. Let's quickly discuss the second approach. So before discussing the second approach, let me write all the possible subarrays for this given array nums. So we will have 1, we will have 1, 0, then we'll have 1, 0, 1, then we'll have 1, 0, 1, 0, then we'll have 1, 0, 1, 0, 1. Okay. Then we'll have 0, 0, 1, 0, 1, 0, 0, 1, 0, 1. Okay. After that, we'll have this 1, then we'll have 1, 0, then we'll have 1, 0, 1. Then we'll have this 0, 0, 1, and we'll have this 1. Now let me also write what is the sum of all these subarray. Okay. So the sum of this subarray is what? It's 1. The sum of this subarray is also 1. The sum of this subarray is 2. Sum is 2. Its sum is 3. Some would be 0. Some would be 1. 1, 2, 1, 1, 2, 0, 1, and 1. Okay. Now let's find out that what is the count of the subarray that has a sum of at most 2. Now, what does at most 2 means? At most 2 means that has a sum less than or equal to 2. Okay. Sum should be either less than or equal to 2. So let's find out how many subarray are there. So 1 is less than equal to 2. This one is also less than equal to 2. 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 This one is also less than equal to 2. This one is also less than equal to 2. This one is also less than equal to 2. This one is also less than equal to 2. So how many subarrays we have got? It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So we have got a total of 14 subarrays that has a sum of at most 2. Okay. Now tell me that what is the number of subarray that has a sum of at most 1. Now what does at most 1 means? At most 1 means that has a sum less than or equal to 1. Okay. So let's see. So this one is less than equal to 1. This one is less than equal to 1. Fine. This one is less than equal to 1. 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 This one is also less than equal to 1. This one is less than equal to 1. This one and this one. So what is the count? It's 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So what is the count? It's 10. Now let's subtract the total number of subarrays that has a sum of at most 2 and the number of subarrays that has a sum of at most 1. So what we'll get? We'll get 14 minus 10, which is 4. And 4 is our answer, correct? So how are we getting the correct answer? So if you'll see properly, then you can find out that what are we subtracting? We are subtracting the common one, right? The one which is common in this one and this one. So which one got subtracted? This one got subtracted, this one got subtracted, this one, 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 and this one got subtracted. So which are the subarray that we are left with? We are left with this subarray, which is 101. We are left with this subarray, which is 1010. We are left with this one, which is 0101. And we are left with this one, which is 101. And what are their sums? 2, 2, 2, 2, correct. All of these are having a sum of 2. So did we notice something? So we can find out the total number of subarray that has a sum of goal by finding out the total number of subarray that has a sum of at most goal and that has a sum of at most goal minus 1, right? What is this? This is nothing but goal minus 1. Our goal was 2. So this is the at most, this is the total number of subarray with a sum of at most goal, and this is the total number of subarray with the sum of at most goal minus 1. And on subtracting them, we will be left with the exact number of subarrays that has an exact sum of 2. Correct. Now, let's see over here. Say for example, this is a number line 0, 1, 2. Okay. So what does at most 2 means? At most 2 means less than equal to 2, right? So at most 2 means less than equal to 2. So what all sums are possible? So it means we can have a subarray that has a sum of 0, and we can have a subarray that has a sum of 1, and we can have a subarray that has a sum of 2. Correct. And what does at most 1 means? At most 1 means less than equal to 1. So what does it mean? It means we can have a subarray that can have a sum of 0, and we can have a subarray that have a sum of 1. Now, if we will subtract them, then what will happen? The common part will get cancelled out, right? So what is the common part? The common part is this one, that they have a sum of 0. So this one will get cancelled out. Additionally, subarrays that has a sum of 1 will also get cancelled out. So what we will be left with? We will be left with only the subarrays that has a sum of 2, right? So how are we going to find the total number of subarrays that has a sum equal to goal? We are first going to find that the count of the subarray that has at most a sum of goal. Then we are going to find the count of subarray that has at most a sum of goal minus 1. And then we will subtract this from this and we'll get the answer. Correct? What did we discuss? We discussed that we'll find the count of subarrays, with at most goal sum, right? Whose sum is at most goal. Okay. And after that, what we'll do, we'll find out the count of subarrays with at most goal minus one sum, correct? And what we'll do, we'll subtract them. And what we'll get after subtracting these two, we'll get the answer. Fine. Now let's see how we'll find this, the count of subarrays that has at most, that has a sum of at most goal, right? So we'll be doing that using sliding window. So let us write the given array over here. So this is the given array. We'll start on by 2 pointers. Let's say this pointer is current and this pointer is release. Okay. Let me represent the release by R. And let's say this is our answer over here, which is initially 0. So what we want? We want at most goal sum, right? So what is goal? 2. Goal is 2. So what we want at most 2 as the sum, correct? So it means that whenever we'll get a sum greater than 2, then what we have to do? We don't have to include it, right? We won't include it. So what we'll do is we will keep processing the elements of this nums until and unless the sum is less than equal to 2. Okay. And the moment the sum will become greater than 2, what does it mean? It means that we have got an invalid window. What does an invalid window means? Invalid window means that this is not what we want. What we wanted was less than equal to 2, right? We don't want greater than 2. So it's an invalid window. So whenever we'll get an invalid window, what we'll do, we will move this release pointer forward and we will release those sums so as to make it lesser than equal to 2. Okay. So let's do a quick dry run, then it would be understood properly. And let's take another variable sum over here, which will keep track of what is the sum until now. Sum would be initially 0. So since we have got a 1, so we will add a 1 to our sum. So what is our sum? Our sum is 1. Now we will check that is this sum greater than 2. So sum is not greater than 2. So it means this is the valid window, right? This case is for invalid window. Invalid window. Okay. Why this is invalid? Because we want a sum less than equal to 2. So whenever we get sum greater than 2, it means that it is an invalid window. So since this is a valid window, what we will do? We will add current minus release plus 1 to our answer. Okay. What is current? Current is pointing at 0th index. This is first index, second index, third index, fourth index. So what is current? Current is 0. Release is what? Release is also 0. Plus 1 will give us what? It will give us 1. So we'll add 1. So what does it mean? It means that we have got a subarray that has at most 2 sum. So what is the sum of this subarray? The sum of this subarray is 1. So is 1 less than equal to 2? So 1 is less than equal to 2. So it means this is a valid subarray. That's why we have added it to our answer. Okay. Now what we'll do, we'll move the current pointer. So current pointer is now here. So what would be our sum? Our sum would be still 1. So we'll check, is this sum greater than 0? So sum is not greater than 0. So what does it mean? It means that it is a valid window. So what we'll do, we will add current. What is current? Current is 1 minus release. What is release? It's 0 plus 1. That is 2 to our answer. So we'll add 2 to our answer. Now what does this 2 indicate? This 2 indicates that we have got 2 subarray that has a sum of at most 2. And what are those subarray? Those subarrays, this one is this 0 and the another one is this 1 0. Okay. So that's why we have added 2. Now again, we'll move the current pointer forward. So now the current is pointing at index 2. And what do we have? We have 1. So we will add this 1 to our sum. So we have got a sum of 2. So we'll check. Is our sum greater than 2? So it's not greater than 2. So it means we are still in the valid window. So what we'll do? We'll say current minus release plus 1. So what is it? It's 3. So what we'll do? We will add 3 to our answer. Now what does this 3 represent? This 3 represent that we are going to add 3 subarrays to answer because we have got 3 subarrays that has at most 2 as the sum. And what are those 3 subarrays? One is this one, another one is this one, and the third one is this one. Correct? That is 1 0 1, 0 1, and 1. Okay. Now what we'll do? We'll move the current pointer forward. So the current pointer is now pointing at the index 3. So what is the element? It's 0. So we'll add 0. So what we have got? We have still got the sum as 2. We'll check. Is this sum greater than 2? So sum is not greater than 2. So what we'll do? We'll find current minus release plus 1. So what is it? It's 4. So we will add 4 to our answer. So what does it mean? It means that we have got 4 subarrays that has at most 2 as the sum. And what are those four subarrays? It's this one, this one, this one, and this one. Correct. So these are the four subarrays that has at most sum of 2. Fine. Now what we'll do, again we'll move the current pointer. So the current pointer is now pointing at this 1. And what we'll do, we'll add this 1 to our sum. So what will be our sum? Our sum will be 3. Now we'll check, is this sum greater than 2? So yes, 3 is greater than 2. Correct. So it means that we are in the invalid window. Why? Because we wanted a sum of at most 2. What does at most 2 means? At most 2 means sum which is less than or equal to 2. But we have got a sum which is greater than 2. So what we have to do? We have to move this release pointer until and unless our sum becomes less than or equal to 2. So what we will do? We will subtract the element present in our release pointer from this sum. So what is the element present in our release pointer? It's 1. So we will subtract 1 from sum. So what we'll get? We'll get 2. And we'll move this release pointer. Now again we'll check that is this sum less than equal to, is this sum greater than 2? So now the sum is not greater than 2. So it means that we are in the valid window. Since we are in the valid window, so what we'll do? We'll say that current, what is current? Current is 4 minus release. What is release? Now release is at 1 plus 1. So what we'll get? We'll get 4. So we'll add 4 to our answer. Now what does this 4 represent? This 4 represent that we have got 4 subarrays that has a sum of at most 2. Let's see what are those 4 subarrays. So it's this one, this one, this one, and this one. Correct. So these are the 4 subarrays that has at most a sum of 2. Now again what we'll do, we'll move the current pointer, then we'll see that we have completely exhausted the array. So what does it mean? It means that we have got the total number of subarrays that has an at most sum of 2. And what is it? It's nothing but 3 plus 2 is 5, 4 plus 1 is 5, 5 plus 5, 10, plus 4, 14. So we have got 14 subarrays that has a sum of at most 2. And you guys have also seen previously that what was the total number of subarrays that has an at most sum of 2? It was 14, right? So what we got? We got at most 2 as 14. The count of subarrays that has a sum of at most 2 as 14. Now let's find out that what is the count of subarray that has a sum of at most 1 by following the same process. What we want to find? We want to find the count of subarray that has a sum of at most 1. What does at most 1 means? At most 1 means that has a sum of less than equal to 1. So what would be the invalid window in this case? Whenever we'll get a sum greater than 1, it means that it would be the invalid window. Correct? It would be the invalid window. Fine. So initially sum is 0, answer is also 0, release and current both are pointing at the 0th index. Fine. Okay. So what we'll do is we will add the current element to our sum. So we'll add 1, we'll get 1. Now we'll check, is this sum greater than 1? So this sum is not greater than 1. So what we'll do, we'll find current minus release plus 1 and we'll add it to answer. So what is current? It's 0. What is release? It's 0. Then we'll add 1. So what we'll get? We'll get 1. What does it mean? It means that we have got a subarray that has at most a sum of 1. What is that subarray? That subarray is this one. Fine. Now what we'll do, we'll move the current pointer. So current is pointing over here. So what we'll do, we'll add this 0 to our sum and we have got a sum of 1. Now we'll check, is this sum greater than 1? So this sum is not greater than 1. So what we'll do, it means that this is a valid window. So we'll find current minus release plus 1. Correct? What it would be? It would be 2. So we'll add 2. What does it mean? It means that we have got 2 subarrays that has a sum of at most 1. And what are those 2 subarrays? It's this one and this one. Correct? Now what we'll do? Now we'll move forward. So our current is pointing over here. So what we'll add? We'll add 1 to our sum. So we'll get 2. Now we'll check. Is this sum greater than 1? So sum is 2. Is 2 greater than 1? So it's true. So what does it mean? It means that we are in an invalid window because we wanted a sum less than equal to 1. Correct? But we have got 2. So what we'll do? We'll move this release pointer and we'll decrement and we'll subtract the element present at the release pointer from this sum until our sum becomes less than equal to 1. So what we'll do? We'll subtract the element present at release. So what is the element present at release? It's 1. So we'll subtract 1 from sum. So what we'll get? We'll get 1 and we'll move the release pointer. Now again we'll check. Is this sum greater than 1? So now the sum is not greater than 1. So what does it mean? It means that we have got a valid window. So what we'll do? We'll find out current minus release plus 1. So current is at 2. Release is at 1 plus 1. Okay. So what we'll get? We'll get 2. So what does this 2 indicate? This 2 indicate that we have got 2 subarrays that has at most a sum of 1. What are those 2 subarrays? It's this one and this one. Fine. Now what we'll do? We'll move the current pointer. So our current is pointing at index 3. So we will add this 0. So what we'll get? We'll get a sum of 1. Now we'll check, is this sum greater than 1? So sum is not greater than 1. So what does it mean? It means that we are still in the valid window. So what we'll find? We'll find current minus release plus 1. Current is 3, release is 1, and we have added 1. So what we'll get? We'll get 3. What does this 3 indicate? This 3 indicate we have got 3 subarrays that has at most sum of 1. What are those 3 subarrays? It's this one, and this one. Correct? Now what we'll do? We'll move the current pointer forward. So current is pointing at this element. So we'll add 1 to our sum. So what we have got? We have got sum as 2. Now we'll check. Is this sum greater than 1? So this sum is greater than 1. Correct. This 2 is greater than 1. So it means we are in the invalid window. So what we have to do? We have to subtract the element present at our release pointer until our sum doesn't become equal to less than equal to 1. So what we'll do? We'll subtract 0. Why? Because our release point is pointing at 0. Correct. So what we'll get? We'll get a sum of 2 and we'll increment the release pointer. Now again we'll check. Is this sum greater than 1? So the sum is still greater than 1. So what we'll do? We'll again subtract the element present at our release pointer. So what is it? It's 1. So we'll subtract 1. Now we'll get 1. And what we'll do after subtracting, we'll move the release pointer. Now again we'll check. Is this sum greater than 1? So now the sum is not greater than 1. So what does it mean? It means that now we are in a valid window. So what we'll do? We'll find current. So current is at 4 and release is at 3. So current minus release plus 1. So what it would be? It would be 2. So we will add 2 to our answer. What does it mean? It means that we have got 2 subarrays that has at most a sum of 1. What are those 2 subarrays? It's this one and these 2, right? Now what we'll do? We'll move the current pointer. So now you can see that we have completely processed all the elements of the nums array. So what does it mean? It means that we have got the count of the subarrays that has a sum of at most 1. And what is it? It's 3 plus 2 is 5, 6, 7, 8, 9, 10. It means it's 10. And we have also seen this when we previously have written all the possible subarrays and we have found out that what is the count of subarray that has an at most sum of 1. So it was 10, right? So it's 10. Now what we have to do? We have found out the count of subarrays with at most sum of 2. It's 14. And we have also found out the count of subarrays with at most sum of goal minus 1. Goal was 2. So 2 minus 1 is what? It's 1. Now what we have to do? We have to subtract them. So we'll subtract 14 from, we'll subtract 10 from 14. What we'll get? We'll get 4 and this is the answer. Now I hope it's clear to you all. So let's quickly code this. So as you all saw that what we were doing is we were finding this at most, right? We were finding this at most goal 2 times. Why 2 times? First we were finding it for at most goal and then we were finding it for at most goal minus 1. So what we can do is we can write a separate function and what we will do in this function is let's call this function as total subarrays with total subarrays at most k. So what this total subarray at most k gives, it will give us the total number of subarrays with a sum of k. Okay, with a sum of k. So what we need to pass on, we will need the vector nums. So we will need vector int nums. And we will also need this k, correct? Fine. So let's take sum initially as 0. Let's take release pointer. It will be pointing at the 0th index initially. And let's also take answer, which would be initially 0. Now what we have to do? We have to iterate over all the elements. So let's say current equals to 0, current less than nums dot size, current plus plus. And what we have to do? We were firstly adding the current element to our sum, right? So what we'll do? We'll say sum plus equals to nums of current. Fine. Now after adding to sum, what we were doing? We were checking whether it's an invalid window or not, right? So if it was an invalid window, what we were doing is, so if our sum becomes greater than this k, right? If our sums becomes greater than k, what does it mean? It means it's an invalid window. So what we were supposed to do? We were supposed to subtract the element present at our release pointer, right? We were supposed to subtract the element present in our release pointer and we were supposed to increment the release pointer, right? Additionally, we have to add one more check over here. That is our release pointer should be less than equal to the current pointer. Fine. Now, if we have got an valid window, then in that case, what we'll do? We'll simply add current minus release plus 1 to our answer. Correct? What we'll do? We'll add current minus release plus 1 to our answer. Fine. And finally, what we'll do? We'll return answer. Okay. Now what we have to do is we have to find the count of subarrays with at most goal as sum. So what we have to do, we have to find the count of subarrays with at most goal as sum. So we'll pass on nums and we'll pass on goal. After that, what we have to find? We have to find the count of subarrays with at most goal minus 1 as sum. So what we have to do, we have to find the count of subarrays with at most goal minus 1 as sum. So we'll pass goal minus 1 as sum. And what we have to do, we have to subtract them. So what we'll do over here, we'll subtract them and we'll simply return this. Return. Now let's run this. So it's giving us the correct answer. Let's submit it. And it got accepted. Now talking about the time complexity and space complexity. So if we consider n as the size of the given array nums, then the time complexity is order of n. Why? Because here you can see that what we are doing in this function. In this function, we are simply iterating over all the elements of our nums, right? So it means that what we are doing, we are iterating over all the n elements of nums, right? So this gives us a time complexity of order of n. But one thing to notice is that we are calling this function twice. So it means once we are iterating over all the n elements to find out the total number of subarrays with some goal, and another time again we are iterating to find out the total number of subarrays with a sum of goal minus 1. So it means that we are having a total time complexity of order of 2n, which would be finally order of n only. Okay. And the space complexity is order of 1 because we are not using any extra space from our end. Correct? So this is all about today's daily LeetCode challenge. Thank you.